Gut. Hm? Nee, ich habe gerade mit ihm gesprochen. Ich kann auch hier bleiben. Weil ihr das da jetzt abgesperrt habt und dann stehe ich quasi außerhalb der Szene. Das ist auch Mist. Ach so. Ja, jetzt stehe ich hier vorne. Das müsste auch gehen. Hier. Gut. Dann. Hm. Katrin? Ah, Kathleen? Kannst du mal bitte nach hinten gehen? Eigentlich müsste ich jetzt schon live sein. Nein, zu dem Technikmann und mal checken, was. Ah ja. Kann man mich hören? Bin ich zu hören? Ich kann mich. Ja, ah ja, wunderbar. Okay. Ja, dann freue ich mich, Sie alle begrüßen zu können zu unserer Live-Vorführung heute hier beim Schweißen. Wir werden heute eine aluminothermische Schweißung mit unserem Verfahren zeigen hier, wie es in Deutschland zugelassen ist und dabei gleichzeitig unsere neuen Maschinen oder Maschinen, die wir für diese Schweißung entwickelt haben, an der Stelle demonstrieren. Wir fangen mit den verschiedenen Schritten an und bauen jetzt quasi die Schweißung auf und die Kollegen werden uns zeigen, wie man diese Schweißung vollzieht. Ihr könnt anfangen. Wir haben vorbereitet. We have prepared the weld according to the standard procedure, in which we have the gap and the alignment already prepared, and we're now preparing the mold and the sealing of the mold with luting sand. And to understand the sealing procedure, it's important to know that we will be pouring about 1 liter, about 8 kilos of liquid steel into the mold. And the steel is as liquid as water, but as heavy as steel. So the pressures from the liquid into the mold are quite significant. And this is why the sealing procedure is absolutely crucial for a weld that doesn't have runouts. Runouts are a significant problem in the field if you do not seal properly. And the luting sand that we use is a method to guarantee a weld that doesn't create runouts. That's in fact one of the reasons why we do not embrace currently technologies that cannot guarantee a runout-free weld. Ein weiterer Grund, another reason to embrace luting sand as a sealing technology is the versatility. So in very rare cases, we have new-on-new rail, but we have worn rail, we have different gaps, we have different sizes, and the luting sand accommodates for any problem that we can see in the field. So any difference in gaps, any difference in rail profile, the luting sand will make sure that the liquid steel does not run out and the weld has to be redone. Now that the mold is readily prepared, we need to preheat both the mold and the rail to not shock the steel with the temperature of the liquid steel that is now about to flow into the mold. And the preheating procedure is absolutely crucial for the weld. We are now presenting our automated preheating device, the Smart Weld Jet, which replaces oxypropane preheating by air propane preheating. And obviously, we need significantly more air into the flame to deliver the same amount of heat, which is why this battery power unit is going to push air with high pressure and high airflow into the mold to deliver an optimum preheating. The machine consists of a turbine and sensors and electronics to deliberately create a turbulent flow to saturate the rail with heat. If we would have quiet laminar flow, the energy from the propane would just go out to the sides. But we want the heat to saturate the rail to have the most efficient preheating procedure possible and to get the fusion zone as wide as we want. Auf Deutsch nochmal gesagt, was wir hören, ist eine turbulente Verbrennung aus Propan und Luft mit einer großen Luftmenge, um sicherzustellen, dass die Wärme der Verbrennung maximal effizient in die Schiene übergeht. Wenn wir eine laminare Strömung hätten, dann würde die Wärme einfach quasi durch die Schiene durchgehen, durch die Form durchgehen und in der Luft verschwinden. Und das, was wir wollen, ist, dass wir die Schiene sättigen mit Wärme, um eine optimale Gefügebildung am Ende der Schweißung vorweisen zu können. Die Vorwärmdauer ist vorprogrammiert und auf das Verfahren abgestimmt, kann aber bei Witterungsverhältnissen oder anderen Gründen manuell verändert werden, um sicherzustellen, dass man immer ein optimales Vorwärmsergebnis hat.
So, das ist, was wir drinnen gesehen haben.
Der heizt nur auf.
Nee, nicht so schwer.
Nee, weil wir drinnen geguckt haben, Mensch, das muss ja auch hier alles wiegen.
Das sah auch so aus, als wenn du das Gewicht da hast.
Vorne.
Ah, guck mal, da ist er heiß genug, dass er
Kaum, ja? Der wird kaum heiß genug.
Pro-Effekt, dann klappt's nicht.
Ja. Genau, so. Und als nächstes legen wir den Filter auf. Wir haben zum Vergleich mal ein Video mitgebracht, wie die Schweißung ohne Filter aussieht, wo man sieht, quasi wie klassischerweise die Schweißung aussieht. Und wie Sie sehen, unter Verwendung des Filters ist im Grunde weder was zu sehen noch etwas zu riechen. Also die sämtlichen Abgase der Schweißung werden vom Filter aufgefangen. Da drin sind an den Seiten 2 Filterkartuschen, die auch mehrfach verwendet werden können, dass wir mindestens 20 Schweißungen mit einer Filterkartusche abwickeln können. As you can see, the EnviroFilter that we put on the weld filters all the exhaust gases from the reaction, both from the crucible that would exit the crucible, but also from the reaction, and make sure that you don't see anything, that you don't smell anything, and that's just the cleanest possible way of performing an aluminothermic weld. We can use the filter cartridges for about 20 welds, and then they get to be replaced. Nach der Vorwärmung schmelzt der flüssige Stahl einen Teil der Schiene auf und kühlt dann ab und verfestigt sich auf eine genau vorhergesehene Art und Weise, um ein ganz bestimmtes Gefüge auszubilden, das nachher die chemischen Anforderungen, die chemischen und die mechanischen Anforderungen an die Schiene erfüllt. Und deswegen ist das Heat Management, also die Menge an Wärme, die man einbringt, so ungeheuer wichtig, damit die Gefügeausbildung auf die genau vorhergesehene Weise stattfindet. What happens now is this solidification of the liquid steel. It first melts a little bit of the rail to create a fusion zone, and then the solidification happens in a predefined way to then create a steel bond that has very precise chemical and mechanical properties. Which is why the heat management is of such importance to make sure that the microstructure of the steel is exactly the microstructure that we intend to create. After a predefined time, we then take away the mold and shear the weld. So the excess steel that obviously sits on top of the weld and that is necessary to create a robust weld to make sure that no small deviations in gap sizes or gap shapes or rail shape would actually create problems. We always have excess steel, and that excess steel needs to be taken away now. Together with the mold. And this is a very crucial operation because obviously while we are sharing it, the steel cools and gets harder and harder and stronger. So it's absolutely important that the weld doesn't get sheared too quickly because that would create cracks, and it also needs to be fast enough so that we don't come into the situation that the steel is already too hard to be sheared. And for this reason, our weld shear has a pressure force of more than 20 tons to be absolutely sure that we can go through the weld at a stable speed, regardless of how wide it is, if it's a wide gap weld, for instance, and regardless of the procedure or process that we employ. And it's also to be noted that the weld shear is powered by the same battery as all the other tools. So it's a commercial battery that can be purchased anywhere from our partner at Ego. And this powerful battery powers all of our tools. Our philosophy when creating and designing these tools is the undisruptive innovation, because our customers have a lot of competence in their processes, and they like these processes because that's what they're trained to do. And our technologies should fit into these customer processes. So there's no hoses, no cables, nothing that disrupts the flow of work on the construction site. So now the weld is sheared. It's still glowing hot. If it was night now, we could still see the glowing hot steel. And now it needs to be ground so that it can be passed. And it's hot ground because it's so much softer. The grinding process is very efficient. And also here we have a non-disruptive innovation. So this is a battery grinder, but except it's not a grinder. So you can use the grinder that your crews are used to. This in this particular case is a Gizma MP6. That is a very well-known machine, widely established in the market. But if you would want to use the Ego batteries, the batteries that power all other of our tools, you can have this upgrade kit where we transform your machine into a battery-powered machine. And then you can benefit from the quietness, the lack of vibration, the lack of smell, to then grind the weld in such a way. Seid ihr fertig, oder? And then finally, after performing the grind and after performing the weld, we also have the tools to inspect either with the rail straight for geometry, and also with the track scan for ultrasonic inspection of the weld. So all the tools that are necessary to perform a weld can be found and acquired here from us. And that was our demonstration. Thank you very much.